Hi there, everybody. Good morning from my side. It's great to see a lot of you that I've known for many years, and now meeting some of you for the first time face to face. It's really wonderful. I've also got a long history in Adabas Natural. I'm now a customer success architect and have been doing this for over 30 years. In fact, following on what Nicole said about the Guinness, I think you've been overdoing it, especially after last night, if you're drinking alcohol-free beer and you're still getting drunk. But my topic is making Adabas more resilient. And wow, that's a big ask, because Adabas has really been really stable, up and running and resilient over many years. But we'll see how to make that happen. So you've already heard about the considerations on why it's critical to have a high availability HA environment as part of your Adabas Natural strategy. This is a picture, maybe not HA, but high altitude. I took in the Atacama Desert, really 5,000 meters, even higher than Everest Base Camp. So just to leave you with that thought. Setting the scene. My agenda, I'm going to set the scene a little bit, going into the key capabilities, use cases, and best practices. Ellie has already told you about the advantages of having a multi-instance distributed architecture. And I will show you how Adabas Cluster for Linux enables your organization to seamlessly operate in case of serious incidents and disasters. That's our purpose here today. The monolithic approach is one that we are very familiar with. Like in the mainframe, you've got your single LPAR, and that's a single instance, and you have a lot of architectures of a single VM instance. Adabas Cluster focuses on high availability, but we'll see other use cases. So this is a journey that we see. It's a phased approach. You'll start possibly with a single instance and then get through to the multi-instance approach. Just a quick question. Off the top of your heads, how many hours do you have a year to get to 99.95 availability? Anyone? I know Eric knows the answer in the back, but yeah? 4.5 hours, exactly. So you don't have much downtime if you want to get to high availability. So here's a traditional representation of one single instance VM machine on one box or one server. And I just want you to think in your mind for now. Keep it to yourselves. Think of two words, mother and planet. Don't say anything, and you'll see in the next slide why. And here we see a single copy of our natural applications, as you saw from Ellie, and a single copy of our Adabas, all under the control of a hypervisor, which is our virtualization layer. And this is a typical architecture that you'll see as a single point of failure. So hopefully you thought of our fragile single Mother Earth planet. And this is a picture I envisaged just to show you a representation of a single instance of Adabas running on this as a single instance. And I ask you, what happens if someone just decides to take an arrow and shoot it down? It's gone. You're left with nothing. So you may say that, I think there was a comment earlier in the back that you've got other options like VM motion and hardware backups and disaster recoveries, but a real use case that we came across was that a customer's VM environment went down. He thought he had all the backups available on a disaster recovery site. It took them 10 hours to get Adabas back up and running, and this is a real live scenario that happened. Unfortunately, they didn't have Adabas cluster services. So, moving on to our cluster architecture, you'll see what we've done now is we've split up the application from the database, and we have our cluster database is based on a shared nothing architecture, which eliminates all possible single points of failure. Currently, only our primary is the read-write nucleus, and the secondaries, the two secondaries, are read-only. They each have their own copy of the containers of their storage. What we need to enable this is the added TCP component to allow us to split the application from the database, as well as you have the ADC component, the Adabas clustered enabled nucleus. So I wanted to just talk to you a little bit about some cluster basics. Computers that are connected in cluster networks are called nodes. And a cluster is a group of two or more nodes operating in parallel. Data replication in a cluster aims to achieve, what does it aim to achieve? A synchronized state between all nodes at all times. So the secondary nodes in our cluster keep the read-only replicas of the data from the primary node. Clusters are also used for different types of tasks. There are high availability clusters, load balancing clusters, storage clusters, and basically high availability clusters are used to increase the fail safety of your system. Another important term is a quorum. What is a quorum? It manages a situation in which the majority, it ensures that decisions are made by a majority of the nodes, so that when there's a scenario where a minority may cause a data corruption, we don't want that to happen. So we have to have in our quorum at least an odd number, 3 or more nodes to maintain the quorum. And this prevents a situation which is called a split brain, where we need to guard against this happening in a cluster. So this is a simplified diagram of our architecture. You see here we have the primary at the top and two secondaries. On the left-hand side, this is the client side. How do we access our cluster from the client? We have something called the DB mapping, and I'm going to ask you a question. Where, for those on Linux, where is the DB mapping? In which directory do we find the DB mapping file? Adabas client. Nice, Chris. It's in the Adabas client directory, and we access that via added TCP. On the right-hand side, we see the nucleus parameters. This is all we need to be able to bootstrap our cluster. We have to give the new parameters, which is the TCP parameter, cluster ports, and cluster URL parameters. Now, behind the scenes, Galera clustering keeps the cluster in sync, and we use a write-set replication. That means that when one transaction is committed, all the nodes will have the same value. And at the bottom, we see that each of the databases has its own associator, data storage, and work data sets. And we've got two new files, the GRA state and the Gcache state, which know how to keep the cluster in sync. So I said a little bit about DB mapping. How do we map the natural application onto the cluster? We can give it one or two ways. Just to update the DB mapping with this logical DBID 66, my physical DBIDs can be the same ones, but in this example I've used 51, 52, and 53. This is the URL so that I can get to it. So in my UDB, if I go into Natural and specify a UDB of 66, which is a logical database that doesn't exist, Natural knows how to get to our current primary node. And we can do all of this by giving the UDB in the Natural parameters as well. Now let's see it in action. Because we're using our imagination, we can envisage not only one single planet in our universe that would be our primary, but we have a secondary as well. So what happens when the primary comes up first, and the first secondary comes up as a joiner? The primary becomes the donor, and the secondary is the joiner. when that's all synced, the next secondary that comes up also becomes a joiner, and one of the other secondaries can be the donor in order not to slow down the primary. So the donor node is the one that executes an ADA-BCK full backup and sends it to the joiner. That's how we synchronize between the nodes. Okay, so talking a little bit about the initial state. When an Adabas node joins a cluster, a state snapshot transfer, an SST, will be initiated. There's another term which is an IST, but I'll talk about that in a minute. So what happens with an SST? The donor node, as you saw, executes a full Adabas backup and sends it to the joiner node, which executes the Adabas restore. This transfers the entire database. And you're going to ask me, I know there's going to be a question about how long does this dump and restore take? Diane's already smiling there, I see. Firstly, the ET-sync parameter is 20 seconds. Now, who remembers what the ET-sync parameter does? Well, I'll tell you. It's the time that the dump will wait for the transactions to synchronize. So if there's an update transaction, it will wait that 20 seconds and then go ahead and back out the transactions in flight so that we can take the dump successfully. The read-onlys continue without a problem. So the time the dump takes depends on the database size, but we've done some testing with a smallish database of around 700 megabytes, and that takes really a couple of minutes. And we even have, Chris will probably tell you more about that at DVLA. In an AWS environment, we have different availability zones sitting on different continents, and the one database came up on one availability zone, the other one came up somewhere else in the world, and it was a matter of minutes. We didn't really feel. But we are currently going to be doing testing with larger database sizes, and so we'll have more information about that. So the other way of the initial state is the incremental state, which this is actually a delta state. So if one of the nodes has been lost from the quorum and it comes up again, then it's going to try and do an incremental state. That's the delta, and it's going to look at these two GRA state. It's going to look at the GRA state file in order to see the delta information and to be able to synchronize faster than an SST and not to have to block the donor. So, what happens now if the primary goes down? Someone takes again an arrow and shoots the primary away. It disappears. The cluster knows that that's happened, and simply one of the secondary takes over as the primary, and we carry on. What happens on the application side is that we will get a response 9, but then we'll continue as normal. We can also switch a secondary to a primary by an operator command. So this is a more traditional way of looking at it. We see here with the primary going down, and then one of the secondaries will take over in that picture. So that what needs to happen is that you need to start up another node as quickly as possible in order to maintain your quorum. Okay, let's have a look at some of the use cases. This picture might look like a 360-degree DevOps view, but holistically speaking, we're looking at some of the typical use cases. The first one is high availability, as Ellie discussed. I think that's clear to everybody. The principles of high availability are to eliminate the single point of failure, to give you resilience and reliable crossover, and failover detection as they occur. The other one, which I have a separate slide on, is the very important fact of the blue-green deployment. I'll show you in a minute. And what about point-in-time backup? Who in the organization is worried about hacker attacks and malware and all of that? So this is a great way of doing it, because we can take backups on our secondary and not to affect what's happening on our main production database. We can take them every half hour, every 15 minutes if you like. So you'll have point-in-time backups that prevent you from replicating bad data to your DR site, because if someone gets in and corrupts your data, that's going to be replicated to all your other servers, and this is one way of alleviating that problem. Sam? One more use case, which I'll show you another slide, is the scalability one. And we have as well an easy way of getting a DR copy that we can put on different availability zones. So, talking about blue-green deployments. As you know, it would allow us to change something in our environment without affecting the availability, so that I can very easily update, for example, a static add a NUC parameter. How do I change my buffer pool size without affecting my current production? I can do that by changing the parameter, bringing down the primary, changing the parameter and bringing it up again and cycling through all my nuclei. And the same goes for new product fixes as well as product versions. So this will give us a true blue-green deployment, either for applying fixes or for changing a static parameter that I would have had to bring down and bring up my database for. Okay, this is the use case of scalability, and Luciano did some work at one of the customers who had a severe bottleneck on a single instance of Adabas. They were hitting it very hard with lots of read-only natural RPCs, and they were getting peaks, and the database could not handle those peaks. So they simply brought up an Adabas cluster environment. They split the application from the database very easily via our TCP connection, brought up another 2 read-only databases, and that alleviated the load on the bottleneck completely on their primary. Now, if you've got scalability issues, you can no one's stopping you bringing up several more nodes, 3, 5, 7, 9, and that could possibly help on read-onlys. So, looking at the cluster status. Someone asked me why I put a picture of grapes here, but I think you guys get it. Hopefully you don't imagine a bottle of wine when you see this, but a cluster of grapes. This is the output of the Adapr new display cluster command. It's a new command, and it shows us the status of our cluster. You see 2 nodes are synced, and this one I caught when it's becoming a joiner, and that will change from a joiner to be synced. So that's one way that we monitor the cluster status. Operating the cluster. Today, the monitoring is a pull mode that we have to run utilities to be able to monitor it, but in the near future, we're thinking of, we're improving that, and we'll see in the features shortly. We can also query the status with Adabas Manager with the REST server interface and get back that information as well. What happens if we wanted to switch a primary to become a secondary? Is a simple operator command that just says switch, and it's immediate. A primary becomes a secondary. We may need to remove the cluster footprint, and I have a slide on that. And when we're using protection logs, just be aware, I would like to make you aware that the ET-sync parameter is important, because we will not see the plog data set on the file system unless we use the ET-sync. If we're using non-ET-sync, then it won't be there until there's enough buffered write IOs. So this is an important parameter to take care of. And as I said, we can set cluster donor name to make a secondary come up and get its donor information from a secondary. we'll see what happens next when we lose the quorum. So there may be instances in which we need to restart our cluster. This is the operations that you need. I won't go into the details, but I'll leave this with you so that if you need to look it up afterwards, if the database fails, we'll have to do an auto restart only, remove the cluster system file, and delete these two files. So it's a simple operation to remove the cluster from a already clustered database if we have to. Okay, what happens if we lose the quorum? What will happen basically is that the number of connected nodes will come down from, if I started at 3, it will come down to 2, and eventually we will see the situation that the only remaining primary node is undefined. Then we know we have a problem with the cluster quorum, and we need to bring up, what's the solution? Bring up another one, another 2 as quickly as possible to prevent the communication breakdown between the cluster and to get it back up and healthy as quickly as possible. So, talking about new features in the next version, which is coming out in October, as I said, we are going to do more in terms of monitoring and alerting. We're going to provide a new alert if there's a mode switch. We need to know about it, because that means that one of our nodes has gone down. We're going to provide more information about that. Today, you get a lot of messages. I mean, the guys who've played around with it see tons and tons of messages. The log level is set today at info, which produces a lot of messages, but we are going to provide a way of changing that to warning on the fly dynamically. And there will be a new get cluster info program in order to query the status of the cluster. Sorry about all these technical details, but Guido said go on a technical deep dive. So. That's it. Some key takeaways, hopefully, that using Adabas cluster will provide us with a transparent and highly available, always-on environment in order to mitigate your organization's risks. And you should include the end-to-end solution with a natural availability server. And we're here to help you. Any implementation, Luciano and myself are here to help you get it up and running. One last slide. What is missing in all this story is the containerization, and that's the next step. Today I don't have time going into that, but we have successfully, Richard is happy with that, have successfully brought up, in fact on the same VM I can bring up 3 of my clustered nodes on one VM and use a fully containerized environment. So before I go on to the questions, I'll just want to leave you with a thought, a spoiler on Chris's presentation, that I just wondered, we had Josh presenting the DMV from Virginia, and now we've got DVLA, but just to make sure that no one thinks that this is anything to do with Los Angeles, right? DVLA is not the Los Angeles Drivers Association, it's the Driver and Vehicles Licensing Agency of the UK. So, any questions? Yeah.
So I would like to know something about the right concern. When you write in the database, do you have several right concern like primary only, majority, or all nodes, to know when the transaction is considered closed? Because if you write in the primary, on the primary say I have the data, but the primary fall down. If you are in majority, for example, the 3 nodes have the data. If you are primary only the primary has the data. So we can lose some information. So I would like to know if the driver can manage this kind of behavior.
As I said, under the scenes, it's all managed by the Galera cluster software. So the state, the write set is a synchronous write set, and it knows once the transaction is completed on the primary, it will replicate it to the secondaries. We shouldn't have any problems with that.
But it's only about the application. The application consider if the primary is okay, everything is okay?
It's transparent to the application. Sorry, I didn't say that. The application doesn't know about it. But if the primary goes down, the application will get a response 9 or a 148 to say that the database has gone down. But that's what happens anyway in your application. You still need to know in your application how to take care of if a database gets a response 9. So...
Okay, but is there parameters to specify if we want all the nodes must be up to date to consider the transaction is okay?
No,
no,
it's a one read only and 2 secondaries. So no, it's not a multi-update cluster. No.
Thank you.
I need to do a selfie.
Sasha, you don't have to query if the you only get an okay state if the data is synced across all nodes on the cluster. You will not, if your transaction goes okay, you will not lose any data. This is considered in the product. Yeah, you only get the transaction okay if the data is replicated. Okay.
Yes.
Is your vision that this is comparable to Sysplex on the mainframe?
Sysplex on the mainframe is a multi-update solution. At the moment, we have only a single update, but it will get there. Yes, it will be very similar to Sysplex on the mainframe eventually, yeah.
I was just wondering about the costs of doing this, because obviously on the mainframe everything is sharing the same data because the same physical data sets are used by multiple members of the cluster, whereas this seems to have a completely new copy of the data every time you create a new node. Does that get very expensive on a cloud platform where you've got 9, 11, 15 nodes of all exact copies of the same data if you've got a big database?
That's a good question, but I think you can set up your storage requirements accordingly on a cloud environment that you can get cheaper storage for the secondary nodes possibly, yeah. But that is a consideration. You would have duplicated data.
Hi, Ilan. Would the mainframe Sysplex give you the same fail-safe mechanism as you're describing here? Do you know?
Yeah, it's a different mechanism, but it is definitely fail-safe. The mainframe is fail-safe. You have your locking structures and your caches, so yes. Your updates there also are totally fail-safe on the mainframe side.
Very interesting, thank you.
Yeah.
More questions? Yes.
Promise I won't talk about Docker. Just a question regarding the target of this kind of architecture is typically a mainframe, because all the nodes should be hosted in a Sysplex, or it's only the target is only Linux system as IaaS?
This is the Linux solution. Sorry, there's a mixed audience, and I didn't expect to get these questions about the mainframe, but. The mainframe solution is a different solution, and that's called Adabas Cluster. That's been going for years and years. We're presenting now the new solution that we have for the Linux, which is the first step in our ongoing journey.
So the target is Linux?
This target is Linux, but we have a solution for mainframe. Anyone who wants the Adabas Cluster for mainframe, it's a perfect solution as well.
I was going to say, in terms of all these mainframe questions, it makes you think back to Monty Python, where they said nobody expected the Spanish Inquisition.
Okay.
Anyone else got a good Inquisition here for him? Thank you, Ilan. That was an excellent presentation. Appreciate it.